Okay, in the last video we talked about sequences in series and we went over all the basic notation for sequences and how they work and definitions, and we went over sigma notation for series and things like that. Now we actually want to look at specific sequences in series that have special properties, and the first thing we're going to look at is what's called arithmetic sequences. As far as definitions go, arithmetic sequences, the terms have a common difference. So essentially the idea is, suppose I have a sequence 1, 3, 5, 7, 9, and so on. If you look at each of the terms differ by 2. That's a common difference. They all differ by 2, which means that's an arithmetic sequence. So we could have something like, again, here, 4, 7, 10, 13. Each of the terms differ by 3, so it's arithmetic. You can also go with something like this. 2, -3, -8, -13, -18, and so on. In this case, I'm subtracting 5 from each term. So -5 is a common difference, and it's arithmetic. So I don't just have to add positive numbers on, I can add negatives. As long as there's a common difference term to term to term, it's an arithmetic sequence. But the question then becomes, how do you write arithmetic sequences in general? Last time we had recursive formulas. And as far as it goes, well, for an arithmetic sequence, a sub n is equal to a sub n minus 1, the previous term, plus, we'll just call it d, the difference, whatever it is, positive or negative. And as far as recursive formulas go, well, it's pretty easy. Take your term, add the common difference, keeping in mind it could be negative. You get the next term, and then you keep on doing that. So that's not a big deal. But we also have what's called explicit formulas. Personally, I prefer explicit formulas to recursive ones, but ultimately, you want to know both of them. The recursive one is pretty simple, so now we want to see if we can come up with an explicit formula for an arithmetic sequence. And well, if we think about it, suppose we have this sequence, we'll say the first term, a sub 1 is 1, and the common difference d is equal to 3. List out the first few terms. Well, a sub 1 is 1, a sub 2, and here I know it's 4, just add the difference, but I'm going to write it somewhat differently. It's actually the first term plus the difference, just like the recursive formula says. So it's the first term plus 3. A sub 3, well, it would be the first term plus 3 plus 3, because it's the previous term, 1 plus 3 plus 3. But then this becomes 1 plus 2 times 3. If we find a sub 4, well, a sub 4, the same pattern will repeat. We'll get 1 plus 3 plus 3, the previous term, plus 3 again, which is 1 plus 3 times 3. And I'm assuming the pattern is obvious now. A sub 5 is 1 plus 4 times 3. If you then generalize that, what would a sub n be? Well, it would be the first term plus, well, a whole bunch of 3's, but how many of them? If we look here, for a sub 3, we had 2 3's. For a sub 4, we had 3 3's. For a sub 5, we had 4 3's. So essentially, we have 1 less 3 than this subscript. So if this is a sub n, we should have n minus 1 3's. Well, now we have a formula that we could use for this particular sequence. to calculate any a sub n. A sub 7 would be 1 plus 7 minus 1 times 3. A sub 14 would be 1 plus 14 minus 1 times 3. So that's an explicit formula to find a sub n for this sequence. But then we can actually generalize this idea for any sequence. So suppose I have another sequence, and I'm just going to let a sub 1 equal a sub 1. Make it as general as possible. I'm going to let my common difference be d. So no numbers whatsoever. Now list out the sequence. Well, a sub 1 is just a sub 1. A sub 2 is a sub 1 plus the difference, d, just like we had over here. A sub 3 would be a sub 1 plus 2 times the difference, d, just like we had here. A sub 4 would be a sub 1 plus 3 times the difference, just like we had right here. A sub 5 would be a sub 1 plus 4 times the difference, d. And then a sub n would be the first term plus n minus 1 times d. And now we have this formula. For any arithmetic sequence, the a sub nth term is equal to the first term plus n minus 1 times the difference for any n. Now that's the explicit formula we care about. So, let's see if we can mess around with it. Let's see, we have a sub n equals a sub 1 plus n minus 1 times d. Once you have that formula, there's a whole lot you can do with it. Essentially, it borders down to algebra and what you know. So I'm just going to look at 1 or 2 examples of different types of problems we can solve and how we can solve them. So first off, suppose we say that a sub 10 equals 14, a sub 20 equals 44. Find a sub 33. Well, what can we do? Let's see. Ultimately, to find a sub 33, I'm going to need that formula. But the problem is, well, in order to use the formula, I need an a sub 1 and I need a d. And how do we find them? We said before that these sequences are just functions. And if you think about it, these functions alter by a common difference. What type of functions do we know that have a common difference on them? Well, lines. The slope is just the common difference, the rate of change. With a line, we call it a slope. Here with an arithmetic sequence, we call it a difference, but it's the same principle. You change by the same amount as you go from term to term to term. Which means, to find the common difference, it's really just finding the slope of that equation right there. But what's our slope? Well, the slope is change in y over change in x. But we said these were functions. This is my domain. These are my x terms. This is my range. These are my y terms. So now I can just plug that into the slope formula and find d. So I do change in y, 44 minus 14 over change in x, 20 minus 10. That's 30 over 10, which is 3. So now my common difference is 3. So I could rewrite that formula, but replace d with what I just found, 3. Well, now I've got part of it done. I need a sub 1. How do I get a sub 1? I need an n and an an that are related. But I actually have 2 of them right here. So I can pick whichever one I want, plug it in for a sub n and n, and solve for a1. I'll just use the first one since it's smaller. A sub 10 is 14. So 14 equals a sub 1 plus n minus 1. N is 10, so this is 10 minus 1 times 3. 14 equals a sub 1 plus 10 minus 1 is 9. 9 times 3 is 27. And then subtract the 27 over. A sub 1 is 14 minus 21, which is negative 13. Now I can fill that into my equation. A sub 1 is negative 13. Well, now I can solve the problem I want because now I have an explicit formula for this sequence. So, what's a sub 33? Well, that's equal to negative 13 plus 33 minus 1 times 3, which is, let's see, 33 minus 1 is 32, 32 times 3 is 96, 96 minus 13 is 83. So a sub 33 is 83. And there we go. Nice and simple and straightforward. These are the type of problems we want to be able to solve with sequences. Yes, we may have to list out a few terms given a difference in a sub 1, but ultimately it's these type of questions you want to be able to solve. Given a couple of random points in your sequence, generate the explicit formula, and then with the explicit formula, solve other questions. So I guess I'll stop right there. If you need more examples of this, you can just rewatch the video or email me and I'll make a few more just going through more problems like this. But once you understand the basic principle, find the slope. The slope tells you your difference. Once you have the difference, plug in one of the points you're given and then solve for a sub 1. Once you have a sub 1, well, that gives you your whole equation. Then you can answer the other questions you have. I'm going to make a separate video on arithmetic series just because there won't be enough time on this one to fully explain them.